Let's prove that the square root of 2 is an irrational number, or is not a rational number. First, let's start with the definition. A rational number is of the form n equals a divided by b, or the ratio of a to b, where n, a, and b are all integers, like 18, 7, -1, -18, and so on. And note that a and b have no common factors. That means that a number like 3 divided by 7 is a great rational number. A number like 9 divided by 12 is not a rational number, because 9 is 3 times 3 and 12 is 3 times 4. Well, these share a common factor. So 9 divided by 12 is not a rational number, but 3 divided by 4 is a great rational number for our purposes. And what we're going to do is what's called a proof by contradiction. And we're going to assume that the square root of 2 is a rational number and show how that leads to a contradiction. So let's assume that the square root of 2 is equal to a divided by b, or the ratio of a to b. And let's go ahead and square both sides. Just do some algebra here. So 2 equals a squared divided by b squared. Multiply both sides by b squared, and we get 2b squared equals a squared. Well, what this tells us right here is that a squared is actually an even number. So a squared is even because it can be expressed as 2 times something. In this case, 2 times b squared. Well, if a squared is even, then that means that a is also even. And we can express a as, let's say, a equals 2 times c, some number 2 times c, right? So a squared is going to equal 2c squared, which is going to equal 4c squared. Great, fantastic. So we have, if we just plug this in up here, we're going to get that 2b squared equals 4c squared. Well, let's divide both sides by 2, and what we're going to get is that b squared equals 2c squared. Well, this is great because this tells us now that b squared is an even number. And what that means is that if b squared is even, then b is also even. Let's say b equals 2 times d, right? Well, that's odd. Well, I shouldn't say odd. That's unusual because if a is even and b is also even, then the square root of 2 equals some even number divided by another even number, a over b, which we're not going to say 2c divided by 2d. Well, look, these share a common factor. And so forcing the assumption that the square root of 2 is a rational number means we actually break the definition of what a rational number is, because there's this common factor of 2 that automatically shows up when we try to do this. Therefore, the square root of 2 is not a rational number. And just really quickly, this was actually a really big problem for the Greeks, because they would say, hey, you can actually construct a triangle, right? That is, let's say length 1 on this side, length 1 on that side. You could take, a foot of yarn or a meter of oxhide or whatever it is. You can actually construct this triangle, and you will get the square root of 2 as the hypotenuse using, the Pythagorean theorem, a squared plus b squared equals c squared. And when you do that, even though it's not a rational number, it still has a real length. And rumor has it that the Pythagoreans killed a guy over this.